In this session, we're going to use Pandas to analyze the Paycheck Protection Program data. Specifically, we're going to take a look at where were the loans made, what's the average size of the loan, and so forth. As a bit of background, the Paycheck Protection Program, or the PPP, was a loan program in response to the COVID crisis. And what we have here is, and it was run by the Small Business Administration, is later, after the loans were made, they put all the data online. So we have loan level data for this program. And what loan level data means is we have data on each individual loan, specifically who made the loan, who got the loan, how much the loan was for, and so forth. Specifically, however, if the loan, the data was put online here, so there's a link to it. If the loan was less than $150,000, we have the actual exact amount of the loan. However, a separate data set was put up for loans that were greater than $150,000. And for these loans, we don't know the exact loan size, we just know the range. So a loan would be listed as here's the lender, here's the borrower, and the loan was between 150 and 350,000, or between 350 and 1 million. So for these large loans, we only have a range. So what I've done is I imported all this data, and I created a large data frame. And in creating this data frame, so I merged these two data sets, and when creating this, I just took the average of these two, and then I posted it on GitHub. So we're going to go ahead and pull that data set that I posted on GitHub and take a look at it. So first thing we want to do is obviously load our libraries, and then we're going to pull the program. The data set is a CSV file. However, because of the size limits on GitHub, I believe it's 700 megabytes. You can't have a file greater than that. And the size of this CSV file was over that. So what I had to do was post a compressed version of the CSV file to GitHub. So what this call will do, which we haven't done thus far, is it's going to, I've passed the argument compression equals gzip. So that's the compression that I used. So what Pandas is going to do here is it's going to pull the gzip file, it's going to uncompress it, and then it's going to import it using read CSV. So Pandas nicely takes care of decompressing the file for us before reading it into a CSV. So let's go ahead and do that, and then once that is imported into a Pandas data frame, we'll go ahead and take a quick look at it. And so here we go. So we have columns on the loan amount. Obviously, this is the amount of the loan. This is the city, state, zip in which the loan was given. This is the NAICS code. This is an industry classifier. So if we wanted to look at, and that would be interesting. We don't do it here, but maybe we could add we could take a look at which industries receive the most money. So that would be an interesting analysis to do. So this gives us the industry, the type of the business type of the borrower. We have race, ethnicity, gender, and veteran. Although what you've seen here is these were obviously not required to be answered. So a lot of these are blank, right? So we have a lot of unanswered there. However, that's in our data set. We also have whether it's a nonprofit. And again, we have a lot of not a numbers. This is not a number. Then we have the jobs reported. So I believe this is the saying how many jobs it would save. The date approved. This is the lender, and we have the congressional district, right? So this is our data set. Good. So the first thing we might want to do is get an idea of the average loan size, median loan size. Take a look at the loan sizes in total and on average. So what we can do here is, remember, this selects these two columns. So what we want to do is we want to see the average number of jobs reported and the loan amount. right? So we can go ahead and run that. It selects these two columns and then calculates the mean of each. And what we can see very quickly is the average number of jobs reported here is 10, and the average loan amount here is 110,000. So we can also check the median, right? So running the median here, we see the median is 3, so the median is much smaller than the mean. So what this would mean is immediately I see this is a rate skewed distribution, right? So it has a long right tail, which is quite common. So in other words, we have a lot of small loans and then some very large loans, and we have a lot of businesses. This is the same distribution that in the size of businesses. You have a lot of small businesses and then a few that are very large, and it pushes the mean to the right. So we can actually test this, however. So we can go ahead and calculate the skewness of this, and yep, we do see on both of these positive skewness. So we can formally get an idea of, yes, this is a rate skewed distribution. And again, we're just using the sort of the structure of taking. Given we want to do this repeatedly, it might make sense to simply create a smaller data frame and then calculate these, say just PPP, jobs, and loan, and calculate these. So we could make this a little simpler by not repeating this portion every time. Lastly, just getting to know the data set here, we can take a look at the total amount of jobs reported and the total loan type. And what we see here is we get the scientific notation. And you might be better than me and can immediately tell what this is. Obviously, this is, you move the decimal place over 11, you move the decimal place over 7. So you could tell that. However, I find it's much easier to format. So Pandas has a lot of different options on how it displays numbers and how it displays anything, strings and so forth. So what we can do is we can set the float format so that when Pandas displays a float, which is this type of number, it will use commas, so that's what we have here, and it'll print 2 decimal places. So if we set that, then we can run it, and what we're going to see is the jobs reported. So this is 50 million jobs, and the total size of the program here is 577 billion. Now, keep in mind that makes the assumption, assuming what I've done is I've just taken the average of the two. So, in fact, the size of the program could be larger. You could find the maximum size by simply, instead of replacing these with the mean, you replace it with the upper bound, and then find the minimum size of the program by replacing it with the lower bound. So, again, that's a mean. Good. So right now we can immediately find something else that's interesting and say, okay, well, how much did it cost to save each job? So here we can just divide the total loan amount. So selecting the loan amount column of the data frame and summing it, right, and divide that by the total number of jobs reported, and we see that for each job saved, right, it cost $11,334 in loans, which seems like a pretty good deal. Good. So this gives us an idea of the entire program. But what we might want to do is take a look at what was the number of loans by state, right? We could also look again by NAICS code, that would be by industry, but here let's take a look at state. And to do this, Pandas provides a very convenient function called group by. So what we can do is we can go ahead and group this data frame by state. But if we're going to group it by state, we're going to have some aggregating function, meaning we're going to have one line for each state. So what should we do to get that one line? We could sum everything, we could take the average of it, and so forth. So here, let's go ahead and take the average. Let me run this. And what it's done is it's dropped anything that it couldn't take the average of. And it's provided the average loan amount in for each state. Note, these are states and also U.S. territories and so forth. So we have AE, so some of these may not be states. We have Washington, D.C. and so forth. They're just all aggregated under state. So what this returns is a data frame with an index that is the state. One thing keep in mind here, this is this is an index and these are the columns, and the mean of the loan amount. Now, keep in mind here, this is the mean of the zip. This doesn't make much sense. Well, it doesn't make any sense. The mean of the NAICS code doesn't make any sense either. So the only really two things that are useful here is the mean loan amount and the mean jobs reported. Right? So we can see in California, the mean loan amount was 121,000 roughly, and the mean number of jobs saved for each loan was 10. Right? So because this, we would probably want to simply select loan amount and jobs reported. Of course, if we're going to feed this into group by, we also have to include the column state, and then this will give us a data frame which makes more sense. It excludes the mean of the zip and the NAICS code, which is nonsense. Interestingly enough, we can also group by more than one categorical variable. So we can group by state and veteran status. So if we wanted to say, okay, well, let's take a look at Alaska. How did the veteran versus non-veteran, what was the difference between the mean loan between veterans and non-veterans in Alaska? So we can say, okay, veterans had a mean loan of 252,000, whereas non-veterans had a mean loan of 162. 18 jobs saved for veterans, 15 for non-veterans. So we can sort by, we can group by multiple groups prior to calculating that mean. And this is very useful. Now, we'll run through two other common tasks with data frames and then we'll look a little bit at pivot tables. But another very common task in a data frame is to subset. We want to calculate means, sums, some metric on a subset of the data frame. So let's calculate the average loan for Maine, Texas, Florida, and Utah. So we can create a list of just the states we want, and then we can subset by state. So state average loan. Let's see here. Yeah. So actually, so this is going to calculate it for just the index. So this is going to calculate it for every state. And what I wanted to do here is show you that that the state is in the index. Right. So the index is actually the state. And the reason why I wanted to do this was, if state wasn't in the index and we wanted to subset by state, then we would, if state was just a column, then we would use this. State average loan, state is in states. However, because state is in the index, we have to use, so this is what's going to create our sort of our Boolean. State average loan index is in states, right? Let's break that apart here really to show you what this returns. We're going to talk a little bit about Booleans. So let me just create a new and show you what this does. So again, this index is because this is, we have to pull the index. If it was just we can do this by any column, but we would have to, if it was just a simple column, we would use this syntax. So what this does is it just creates an array of Booleans here. So false, 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 true. So this says, is it in the state? Right. So then when so this is our array of Booleans. And then what this will do is return, this state average loan has all the states, right? So state average loan. So this will be all the states, right? So what this will do, this syntax here, is it's simply going to, from all the states, choose those where the Boolean is true, right? And that is going to be Maine, Texas. So that's how we would do it, just using this is in. So just we're saying, is it in there, return true or false, and then and this will select anything that is true. And that'll return our that'll return our data frame of just Maine, Texas, Florida, and Utah. Good. Or we could also we could exclude those if we'd like. So if we include the tilde prior, it's going to reverse the Boolean, right? So here, let's do, so now we've just reversed, so this is not. You may be, I don't know, it's common, in other languages, I might use the exclamation point for not, but here it's the tilde. And again, it just reverses the Boolean. So is in states, and then tilde would be is not in states. So in other words, we wouldn't use a different function. You don't have to say is not in. You just say not is in, and that will return all the states which are not in our state list, all the states which are not Maine, Texas, Florida, and Utah. And there we get that. And of course, if we wanted, we could sum over this data frame. So if we wanted to get the state average loan over, excluding those states, right? So we could sum over that and get the number. It's also very common, again, this is gonna use a Boolean again, to filter. So what we could do is we could say, okay, well, return any state which has jobs reported, the number of jobs reported is greater than 12, the average. Right, so this actually we've calculated above, so we really don't need to recalculate it, but we're just recalculating it here. And then this will create a Boolean that's true for any state where the mean job reported is greater than 12, and then this will return the list of states. So we can go ahead and run that, and we see these states have a mean job reported per loan greater than 12. So Washington, D.C., I believe that's Guam, Indiana, Kentucky, Ohio, Pennsylvania, and so forth. I'm not sure. American Samoa, maybe. But again, it just uses this creation of a Boolean. And again, you can see, you can see the creation of the Boolean by just running that. And we can obviously change this and so forth. And this can be a variable in some function. We could create a function with this that would allow the user to input whatever the threshold is, and it would return the states. Now, one thing you may be thinking here, if you're coming from Excel and have used Excel a lot, is, well, what I really want to do is just create a pivot table. So Pandas also, and I use pivot tables all the time, so having a pivot table in Pandas was very nice moving from Excel to Python. I'm already thinking in pivot tables from Excel, so I can just continue that and create pivot tables in Python. So what we'll do here is we'll create a pivot table. So the value in the pivot table is going to be the loan amount, the index is going to be the state, and the column is going to be the veteran status. So we can go ahead and take a look at that. And right there with that brief line of code, we have state in the index here. And then we can look at the loan amount. This is going to be the total loan amount. So I have the average NumPy sum here. So this is the total loan amount, not the average, total, by veteran status, right? So if you're used to thinking in pivot tables, you automatically have that here, and it's a great way to summarize the data, right? So the arguments here are the data frame, we have the values, we have the index, we have the values that we want, we have the, we can have a category of veteran, and then how we want to aggregate the loan amounts. Excellent. So what we've done here, taking a look at this, I was wondering if I wanted to see how many states had the total amounts to veteran-owned organizations was greater than non-veteran. So now one thing to think about, it's very common. So if you notice here, let's say I wanted to compare veterans with non-veterans. Well, here we see the veteran, I guess there's no loans to veterans in this, in AE. I'm not sure what territory that is. But so we would want to get rid of this, right? So, and we also need to get rid of this, American Samoa, because this is also an NAN. So a very common, it's very common when dealing with a data set like this to immediately say, okay, well, I want I want only columns that have a complete set of data. So I want only, I'm sorry, I want only rows which have complete sets of data. So the idea here is I only want to keep states where I have loans for veterans, non-veterans, and for each, and unanswered for each column. So we can do that by using this drop NA function, right? So we want to drop NA, axis here is rows, and then again with our in place is equal to true. We can do that, and now we have data in every column for each row. So all rows have a complete set of data. And that is, like I said, extraordinarily useful. We can, here I have also that we could, if we would calculate the median, should we calculate this for the mean or the median? Let's actually calculate it. So I'll tell you what, we already have the mean, so we can change the median. This aggregation function can be, yeah, I guess we want to do this. Let's do it for the median. So this aggregation function can be sum, median, mean, and so forth. So now let's create a table which we're going to add an indicator function. And let's take a look at the table. Now that I've done this, we're going to have some. Let's rerun. Pardon this, but let's rerun this. We're going to look at the median, but I want to drop any. I want to drop any NAs here as well. So we'll go ahead and paste that there. So we'll take a look at it. And now we have the median, and we have no NAs. So let's create a new column in our data frame. So this is going to create an indicator column, and it's going to indicate whether the median veteran loan was greater than the median non-veteran loan. So we can go ahead and run that, and let's go ahead and take a look. I was just going to add a cell here to take a look. I'm just going to print the table, and we should have a new. That is, we should have a new column, which is that indicator. So this is true. This is true, right? Less, so it's false Connecticut. So everything it's behaving like we expect. Now, let's take a little bit of a second to look at the behavior of Booleans. So again, Boolean is going to show up as true and false. So I can just take a look at whatever this would be the 7th. It's false. We can take a look at the type of this, and it's going to return numpy bool. But a really important thing to know is that if you try to multiply a Boolean, right, it will convert it into a number. So this was false, right? So if I take this table, this false, and I multiply it by 1, it's going to, well, what was this? Table indicator 0. What was 0 here? 0, which should have been true, yeah. So it returns 1, right? 6 was false. So if I have 6 here, this should return 0, right? So multiplying true or false by a number will, return the number. All right, so 1 is true, true is 1, false is 0, right? So we can operate on Booleans in such a fashion. Let me see if I can undo that. Well, put this back here. Good. So what we can do, and this is actually probably needlessly, I just was formatting it here. So let me get, so the result is going to be, here was 84.48, but let me get rid of the formatting, so, because it'll just be a little confusing. So what we can do here is we can sum the indicators, right? And this is going to give us the total number of trues, right? So here, we can add that back in. So if we want to get the total number of trues, there's 49. Now remember, there's about 56 or so states. So so there's more, but this is pretty much all the states are where the median loan to veterans was greater than non-veterans. So we can get the average. Well, let's say we can get the total number of states. Let's take a look at that. So that was the table, and then we can pull the shape attribute. And we want the number of rows. 55. So there's 55. So if we want to get the average, right, or the proportion, what proportion, what percent of states had veteran-owned median loans were greater than non-veteran, we can divide this. Go ahead and get rid of that there, and we should see 89. Excellent, 89. I think the 84 was I was doing that with the sum. So, and then again, as I had before, you could print this. You could print this a bit better, but 89. Excellent. So this gives you an idea of how we can start subsetting the data and start answering questions that people have. Again, there's a we've done this with veteran here. We can easily look at industries and so forth. So we're just giving you an idea of how you can calculate interesting statistics from the data. Lastly, we can take a look at which states have the most jobs saved per dollar of purchasing PPP loan. So what we're doing here is we're trying to find sort of which state has made best use of the loan. So we're looking for a maximum of sort of the number of jobs saved divided by the loan amount. But notice that's equivalent to minimizing the loan amount, the reciprocal, the loan amount divided by the number of jobs. So we can go ahead and do that. Get our total loans. Right, so this is just getting our total loans per state. So this is going to give us the total loans per state. And then this is going to give us the loan per jobs data frame. So this is going to be the total loan per state divided by the total jobs saved per state, right? So that should give us this here. And then what we can do, this is just naming the column, right? So I'm just setting the name of the column to loan per job. And then I can sort this data frame. So our data frame is loan jobs data frame. We can sort this and just look at the first 5 rows. And we can see the lowest loan of jobs, meaning the highest job per loan ratio, is American Samoa, I'd say Puerto Rico maybe. So it's these are all not actual states; these are territories, which is actually interesting. Let's look at so these are where we got the biggest sort of bang for our buck. Guam, Virgin Islands. Let's look at where we got the worst. It's interesting. Massachusetts, Virginia, D.C., Washington, and AE, no data. Excellent. So that should give you an idea of how you can just start slicing, dicing, and analyzing a data set using Pandas like you would do in Excel. So for an exercise, calculate the maximum and minimum amount of loans offered through the Paycheck Protection Program. So again, reiterating, what I've done here is for this, when the loan amount was this, I just put it in the average, right? So what you can do, how I would do this if I were you probably, is I would create an indicator that says if the loan was 250,000, right? Create an indicator over here, and then for those different indicators, you could add in 350, replace sort of 350, 1 million, replace 250 with 350, 725 with 1 million. So this is the exercise is somewhat involved. You have to again, probably the easiest way would be to create indicators, and then you're going to have to sum over these different indicator columns. So this will give you a good exercise. But at the end of this, you'll have an answer of this is the maximum size of the PPP, or this is the minimum size of the PPP.